Good morning. Today we discuss about the principle of communication, which is the third sem electrical engineering subject, and we discuss about the introduction of basic principle communication. That is the first lecture of this subject. So what is the basic communication system? In communication deals with the principle of transferring information from one place to another. It means that the information are transmitted from source to destination or one place to another place. This is the communication system. It involves transmission and reception and processing of information between these two locations. There are two locations basically we use in communication system. First one is the transmitter part and second one is the reception part. So the information transmitted between two source and destination points, that is the uh, transmitter or receiver parts. Between these two parts, two source could be in the continuous form, as in the case of analog communication. We know that in analog communication the source is continuous form. It means the value of voltage or current vary with the time. That is the analog communication. And discrete signal means in digital communication, as in the case of digital communication. In digital communication or discrete signals, the signal in break into different parts as per the time of the analog signal. So short distance transmission of information is called baseband transmission. This is the short distance transmission of information is called the base transmission. For long distance transmission, information has to be impressed upon a high frequency component. High frequency means frequency have the range of kilohertz, megahertz, and also gigahertz to be able to reach the reception end of communication. In this long distance communication, the higher frequency generally used, and these frequency signal are transmitted from source to destination, and that signal received at the reception end. So that is the long distance transmission system. The high frequency component is termed as a carrier. We also know that the high frequency signal, also called as a carrier signal, or low frequency signal called as a wave signal or modulating signal. So the high frequency signal is called as a carrier signal. In this process, the entire process is called modulation. This process is the modulation. In modulation, signal transmitted from source to destination. This is the modulation part. In next, where the signal is received, that part is called the demodulation or receiver parts. So the modulation or transmission and receiver or demodulation is the same. So what is the modulation? In communication system, the modulation process have the important role in communication system. In modulation system, to translate the frequency of low pass signal. Low pass signal means the frequency have the in the range of 500 hertz, 1000 hertz, and up to maximum kilohertz. Signal to higher band, so that spectrum of the transmitted band pass signal match the band pass characteristics of the channels. Lower band to higher band, the difference between these two frequency, higher band to lower band, that is called the band pass filter. So the in modulation system, low pass signal is transmitted to higher band or higher frequency, so that spectrum of the transmitted band pass signal match the band pass characteristics of the signal. The matching is very important part in communication system. The signal should be matched with receive signal, which signal is transmitted, that is matched with receive signal. For efficient transmission, it has been found that antenna dimension has to be the same order of the magnitude as the wavelength of the signal being transmitted. Here the antenna. So antenna is the very important part of the communication system, and the dimension of antenna depend on the signal wavelength and frequency of the signal. So the height of the antenna depend on the wavelength of the signal, frequency of the signal. For example, since C equal to F for a typical low frequency signal of 2 kilohertz, that is the typical low frequency signal, 2 kilohertz, and we choose the wavelength for this work, suppose 150 kilometer. So what is the length or height of the antenna? So height of the antenna would be lambda by 2. The height of antenna h equal to lambda by 2. Here the lambda is given 150 kilometer. So the height of the antenna h will be 150 divided by 2 equal to 75 kilometer, which is the height of the antenna. So the height of the antenna depend on the frequency of signal and wavelength of signal. This is the formula for the height of antenna determination. Next, to enable transmission of a signal from several message source. Several message source means different frequency signals simultaneously through a single channel employing frequency division multiplexing. That process is also called the FDM, frequency division multiplexing, in which message source simultaneously through a single channel employing frequency division multiplexing to improve noise and interference immunity in transmission. The role of the noise and interference is very not beneficial for in communication system. Now we consider and try to improve the noise and interference immunity in the communication system or transmission system. over a noise channel by expanding the bandwidth of the transmitted signal. So the noise effect will be on the bandwidth of the signal. And what is the bandwidth? Basically, bandwidth is the difference of two frequency, or higher frequency minus lower frequency. That is the bandwidth. Bandwidth, or means we can say that the path of communication is called as the bandwidth. Next, frequency transition. Frequency translation. The modulation process shift the modulating frequency to a higher frequency. We know that in modulation process, the frequencies are shifted by the method of modulating from low frequency level to high frequency level, which in turn depend on the carrier frequency. And this frequency, basically modulating frequency, depend on the carrier frequency. Carrier frequency is the higher frequency signal, and modulating frequency signal is the lower frequency signal. So the modulating frequency signal depend on the carrier frequency signal, thus producing upper and lower sideband. And the method of modulating signal processing, the at the output or at the demodulating end, the frequency divided in two parts, upper side band and lower side band. Hence, signals are up converted from low frequency to high frequency. In this process, in modulation process, the signal are converted from low frequency to high frequency, and down convert from high frequency to low frequency in the receiver. This is the conversion process. We can also say that in transmitter part, the low frequency converted into high frequency, and at the part of the receiving, where is the receiver, the frequency converted from higher frequency to low frequency. So this is the process in transmitting and receiving part, or at the transmitter or receiver. This is the frequency translation system. The process of converting a frequency of a band of frequency to another location in the frequency spectrum is called frequency translation. That is the frequency translation. What is the frequency translation? The process of converting frequency or a band of frequency, okay, to another location in the frequency spectrum. There is a frequency spectrum, and there is different frequency, low frequency, high frequency, medium frequency. So this process is called the frequency translation. Next, now we come on the different type of modulation process which are generally used in transmission or communication system in communication engineering field. So depending on whether the amplitude, frequency or phase of the carriers, it means that the modulation process depend on the signal, amplitude, frequency of signal and phase of the signal. These are the some parameters on which modulation process dependent. The carrier is very in according with the modulation signal, and we classify the modulation as amplitude modulation system or AM system, frequency modulation system or FM system, phase modulation or PM system. So there are basically, we classified the modulation system in three types. One is AM modulation, second is frequency modulation or FM, third one is the phase modulation or PM modulation. So there are three types of modulation system which are generally used in transmission system or communication system in engineering field. Now, the method of converting information into pulse form and then transmitting it over a long distance is called the pulse modulation. So this is the pulse modulation process. This is the part of the digital communication system in which pulse modulation system, the method of converting information into pulse form. It means a continuous wave is converted into the pulse form, and then after converting the pulse form, then these pulses are transmitted over a long distance. So this process is called as a pulse modulation. So that is the digital modulation system. Now, the message as it arrives may not be suitable for direct transmission. Okay, the message as it arrives may not be suitable for direct transmission, or which message which have some noise interference. This type of message is not transmitted direct in the form of direct. So it may be voice signals. The signal may be voice signals, music signals, picture signals, or data. These are the different signals, music signals, picture signals, or data signals. These are the different signals which is generally used to transmit from source to destination in transmission system or communication system in communication engineering field. So the signal which are not of electrical nature, the signal which are not of electrical nature have to be converted into electrical signal. For example, the data signal is not a form of electrical signal. So first of all, we convert data signal into electrical signal. So this is the conversion process. We can do this with the help of transducer and other device. So the different signals which is not in the form of electrical nature, that are converted first in electrical nature and then transmitted on transmission in transmission system. So have to convert it into electrical signals. This is the role of transmitter. This process, conversion process, is occur in the transmitter system. So typical block diagram is illustrated below here of the transmission and receiver system. So in this first block there is the carrier crystal oscillator. So generally जो crystal oscillator used for generate the carrier signal. Carrier signal means high frequency signals that is generated by the crystal oscillator. Crystal oscillator is the electronics device which is generally used for generate the high frequency signal, that is the carrier signals. And next, this signal transmitted to a buffer amplifier. The role of buffer amplifier means if signal have the low amplitude, so this buffer amplifier increase the strength of the signal that is the received by the crystal oscillator. And next, this signal transmitted to the voltage and power amplifier. And there is the different type power amplifiers which is generally used in class A power amplifier, class B, class C, or push-pull amplifier. So we are generally used in this transmission system, a push-pull amplifier. That is the more beneficial as compared to class A, class B, and class C power amplifier. The role of the power amplifier means it increase the strength of the signal, increase the strength of the signal which is received by the buffer amplifier. And next, after the power amplifier, the signal transmitted to the modulator power amplifier matching network. In matching network, the signal is matching with the modulating signal. The carrier signal is matching with the modulating signal, and that process occur in the modulator power amplifier matching network. And next, after this network, the signal again transmitted to the voltage and power amplifier. And power amplifier means increase the strength of the signal. So there are basically two signals, modulating signals and carrier signal. These are both signal are superimposed to each other, and after this modulation process, the signal transmitted to the receiver end parts, and at the receiver system, the reverse process is performed. That process is called as the demodulation process, or the modulating signal received at the demodulating part by method of the demodulation process. In demodulation process, the original signal or modulating signal is received at the end of the receiver. So this is the modulation and demodulation process in communication system. So basically, there are two signals are used for modulation and demodulation process. One is the carrier signal, and second one is the modulating or base signal. This is the modulation and demodulation processing. And now at the receiver, a receiver is meant to receive the electromagnetic signals. Electromagnetic signals means high frequency signal or carrier signal which have the frequency of the electromagnetic signal equal to 3 into 10 to the power 8 meter per second. This is the also velocity of light signal. So this is the electromagnetic signal at the receiver, in the receiver parts, is tuned to receive the required information. Required information means base signal at a predetermined frequency. The output of the receiver is usually fed into transducer, which convert. What is the role of transducer here? Transducer convert the information into understandable signals. This is the role of transducer. So we see in this diagram, here is a mixer and one is the RE amplifier and second one is the local amplifier. Local amplifier generate the high frequency signal and RE amplifier generate the base signal. So these two signals are mixed in the mixer, and after mixing the signal, the output of the mixer applied to the intermediate frequency amplifier or IF amplifier, and then after IF amplifier signal applied to the demodulator process or demodulation or receiver parts. In receiver, the original signal is received by the method of demodulation process, and after demodulation process, we have the original signal, modulating signal or base signal. That base signal is the audio voltage and power amplifier. The signal may be audio signal, picture signal, or data signal, and that signal applied to the power amplifier. The role of power amplifier: receive the base signal or modulating signal. The power amplifier increase of this signal, the strength of increase of this signal, and after increasing the strength of the signal, and finally we receive the original signal at the part of the receiver. So this is the ending part or receiver part of the signal. So that are the both process, modulation and demodulation, in this topics, and we have discussed about these modulation process and demodulation process. So the role of modulation and demodulation is the important role in communication system or transmission of a signal from source to destination or one place to another place, and different modulation process are used in as per requirement, as AM modulation, FM modulation, phase modulation, pulse position modulation. Also, we classified the modulation system in analog modulation system and digital modulation system. Next, now we discuss about the multiplexing. What is the multiplexing? What is the role of multiplexing in modulation and demodulation system process? when it is required to transmit more signals on the same channel. We want to more than one signal transmitted on a single channel. So baseband transmission fails as in the case of audio signals being broadcast from different stations on the same channel. This is the multiplexing. So what is the multiplexing? Multiplexing, it is required to transmit more signals or more than one signal on the same channels. Baseband transmission fails as in the case of audio signals being broadcast from different stations on the same channels. This is the process of multiplexing. And next, to encounter this problem, either frequency division multiplexing or time division multiplexing is employed. There are two methods for multiplexing. First one is the frequency division multiplexing or FDM, and second one is the time division multiplexing or TDM. There are two methods which is generally employed in multiplexing processing, TDM and FDM, frequency division multiplexing and time division multiplexing. So this method of transmitted several channels simultaneously is known as frequency division multiplexing. What is the FDM? In FDM, the transmitting several channels simultaneously is known as FDM. What in time division multiplexing, TDM, several channels are transmitted over a time interval. There is a time interval, a particular time interval. The time may be in millisecond, in microsecond intervals. So each signal is allotted a time slot, okay, in TDM system, and it gets repeated cyclically after a particular time interval. The only difference between FDM and TDM is that signal are to be sampled at a particular rate. Signal are sampled at a particular rate or a particular time interval. Time interval is very small. The range of millisecond, maybe microsecond, or maybe nanosecond. This time interval is very small. So there are two methods generally which is used in multiplexing systems, TDM and FDM. And next, now we come on signal introduction. What is signals? So what is signal? So signal is any function that carries information. Signal means any function that carries information. The information may be data information, audio information, video information. The information may be different, and signals show how a parameters vary with another parameters. Signals show the how a parameter vary with another parameters, and will be dealing with signals with time or frequency as a independent variable. So the time or frequency, the relation between the time and frequency, t equal to 1 upon f or f equal to 1 upon t, or we can say that the frequency inversely proportional to the time. So this is the relation between the time and frequency of a signal. So we can classify the signals in different forms such as continuous and discrete signal. Continuous means analog signals. Analog signals means the value of signals or the value of voltage or current vary with the time. That is the continuous or analog signals. And next one is the discrete signal. Discrete signal or digital signal is the same things. In discrete signal, we break the analog signal into the different discrete parts as per frequency or time slotting. So there is continuous or analog and digital or discrete signals. Next one is the casual and non-casual signals. These are the also classification of the signals. And next one is the even signals or odd signals. And next one is deterministic and random signals. This is the also signals and real and complex signals. So these are the different signals which is generally used in communication or transmission systems. These are the some signals: continuous, discrete signals, casual, non-casual, even, odd, deterministic, and random signals, real and complex signal. These are the different signals which is used in communication system or communication transmission system. You see in this slide, this is the example of digital signal or discrete signal. Here you see the analog signal is break into different impulse as according to that time. So this is the example of discrete or analog, discrete or digital signal. And this is the example of analog signal. You see in this slide, that signal is the example of analog signal. In analog signal, you see here the wave of analog signals is continuously change with the time, or we can say that the voltage or current of any signal is changed with the time in analog signals. So these are the basically mainly two signal, analog signals and digital signal. The analog signals are generally used in analog modulation system, and digital signals are generally used in digital modulation system. There are some advantage and disadvantage of both signals. In analog signals, there are some interference or some noise are involved during the process of modulation. So there is some noise and interference exists in analog system or analog modulation system. But in digital or discrete signal, the chance of interference and noise is very low or very minimum. in digital or discrete modulation system. So nowadays, the digital system is generally employed for transmission of a system. For example, in mobile system, TV system, and LED, LCD, and different communication, the sound is very clear in digital modulation system because there is no interference and no noise exists in digital communication system. So digital communication system is more beneficial today in communication system as compared to analog communication system. So there are basic introduction of different signals. Now some books are for this topic we refer. First one is the Principle of Communication. Author is George Kennedy. And second one is the Analog Communication. Author is D.P. Lathi. So these two books are cover all the introduction of this communication system. So you can refer these two books for as a reference books. Next, some multi-choice questions are given for you. There are total number of 10s. These are the basic MCQ of this topic. And this question help you to understand this topic and clear the fundamentals of concept of this topics. So you attend these MCQ. There are total 10 questions of this topics. So I hope this topic is very helpful to understand the basic communication system. So thank you very much.